So previously we have discussed row echelon form of a matrix. Also we have defined reduced row of a matrix. Reduced row, that was RREF, reduced row echelon form. And then we have defined that rank of a matrix, and we have seen how they are connected to each other. Okay. The rank of a matrix can be defined in terms of number of linearly independent rows or number of linearly independent columns. It can also be defined first finding the row echelon form and check how many rows are non-zero. So that number will be the rank of a matrix. Now this rank of a matrix is very important for studying the solution of a linear system. How many solutions are there and how many whether the system has exact unique solution or many solution. This kind of information can be obtained from the rank of a matrix. So this rank of a matrix is very important. It can be used in several engineering applications also. This concept will be repeated in your maybe not in mathematics also. So if you try to solve some mathematical model in your engineering problems, then you can see this idea will be coming at rank of a matrix, how to use. So just to recall again that row echelon form, it will satisfy property 1 and property 2. But for reduced row echelon form will satisfy property 3 and 4 including these two. So reduced row is a
Sir, have you started?
more specialized one. Yes.
Have you started showing presentation? Sir? It is not showing.
I can see it.
Can you
Yes, I can see it.
rejoin? Yeah, once leave it and then rejoin again. Then maybe this problem can be solved.
Okay.
Okay. So for reduce row echelon form, it is we may have a structure of this form either A or B or C type. But for reduced row echelon form, or actually we will have of this form, and this reduced row echelon form is unique for a given particular matrix. So these are we have seen in the previous lectures. Now we want to study that solution of a system of linear equation. Since this is a 3 by 3 system, so you can find the determinant and you can always use the Cramer's rule to find out x, y, z. That is we have learned in our school mathematics. But we have to, if we have in place of these 3 equations and 3 variables, if we have, for example, 100 or 1000 variables and maybe 1000 equations, then how to solve? Can you find this determinant? I mean, hand calculation is not possible also for each case. Even if for that we have to study the concept of generalized system. That means in place of this number of 3 or 100, we will write as m equations and n variables. So this is our goal to study. but we'll explain this with an example. So this system can also be written as in the matrix form. So from here you can write. Let us write the coefficient is 1 here, 2, 3, 2 and 3. The coefficient here is 3, 4 and 1. 3, 4 and 1. Coefficients of this third equation are 2, 1 and 3. So we can rewrite the system as x, y and z. And the right hand side we can write it as a vector form or as a column matrix. Okay. Now this matrix is called coefficient matrix. If you write this system as ax equals to b in a short form, then this matrix is here a equals to 1, 2, 3, then 3, 4, 1 and 2, 1, 3. So this is one matrix. And X matrix is the unknown vector. That is X, Y and Z. And B is the right hand side vector. So that is 4, 5 and 6. So this system can also be written of this form. Okay. Now there is another concept called augmented matrix. For augmented matrix, what we will do? We will include these coefficients, that is the right hand side vector, in this matrix and will increase the size of the matrix. Augmented means you have to, that means increasing the size of the quantity, whatever the quantity is given. Here the quantity is matrix. So it is a 3 by 3 and we are increasing the size of the matrix. Okay. For example, if you have a function f of x equals to some maybe ax square plus b, and then g of x probably if you have some x. Okay. Then if you write fx plus some k times g of x, then we can say that f is augmented. That means we are increasing the size of the matrix, here the function. So augmentation is the increasing the size of the matrix in this case. Okay. If you want to find out the dictionary meaning of augmented, so you can find it. But in our case, let us understand in this way that we will either we will put dotted line here or we will put a solid line to separate the coefficients of the left hand side coefficient, and then these are the right hand side coefficients. So this 4, 5 and 6, 4, 5 and 6 here, and these are written in this form. So make it of this form. So this is augmented matrix we will write. Now this concept will be used to study the nature of the solution of the given system of linear equation. Okay. So as we have mentioned that we want to study the form of what will be the solution of a linear equation of a system of linear equation. Then if we have in place of 3 variables, now if we have n variables, then the coefficient matrix here it will be of this form: a11, a12, a1n, a21, a22, a2n, am1, am2, amn. Okay, this is M by N matrix. And then we will have a vector which is unknown, x1, x2, and xn. These are unknowns. And this will be known. Here B is the vector b1, b2, bm. Okay, Aij and Bj all are known. Only thing we have to find out what are the values of x1, x2, and xn. So that's our task. Before we proceed further, let us define two. Let us find out. Let us understand the definition of two important definition for which we call it the system is said to be homogeneous if the right hand side vectors are 0. If any at least one is non-zero, for example, this is 1, then we call it a non-homogeneous system. Okay. Now a linear system is said to be consistent if we have at least one solution. If there are no solution, then we call it inconsistent. Now a consistent system can also be divided into two class of problems. One is having unique solution, another is solution more than one or infinitely many solution. Unique solution or many solution. In case of two also we'll call it a many solution. Okay. Now as you know that when we have a system of linear equation, then for example it is in two-dimensional case. Case. For example, ax plus by equals to some c1 and sorry a1 plus b1 equals to some c1, a2x plus b2y equals to some c2. If we have this kind of two variable and two equations, then solution of this system means they will have a common point, or if these two lines are overlapping. For example, this is for example, okay, y equals to some this can be written as y equals to mx plus y. So this is a straight line. If the straight lines are actually overlapping to each other, then we will have many solutions here. But here only one point intersection, then we will have only one solution. If there are no intersection points between these two lines, in two-dimensional, these are lines. So we call it inconsistent. That means no solution here. Okay. Now if you generalize this concept to three-dimension, then what will happen? In the three-dimensional case, what we'll have, three space means three-dimensional space, 3D space. For unique solution, we will have now the straight lines are now planes. Okay, it has three variables, one constant. For example, ax plus by plus cz equals to d. Okay, for this one, this plane. So equation of plane of this kind. Similarly, this can be generalized as a, for example, a1, b1, and c1 into d1. Then a2 x plus b2 y plus c2 z equals to d2. Then a3x plus b3 y plus C3 z equals to D3. If we have three different planes and if they intersect at one point, then we will have consistent system, and this is a unique solution. Now, for consistent system, we may have infinite number of solutions also if they intersect at a line of intersection. Here we have point of intersection. These three planes are intersecting exactly at one point. But for this case, what happens? There's line of intersection. They are intersecting at a line. Now we know that in a line, how many points are there? Infinite number of points are there in a line. So there will be infinite number of solutions in this case. Okay, so this is also consistent. This is also consistent and consistent. Unique solution, many solution. But if we have system like this, all are parallel lines. They do not have intersecting points or intersection of line. So what happens here is we do not have any solution for these systems. Okay, if these three planes, for example, this is a system of linear equation. If you represent in the graphical sense, then it will look like of this form. So if you have this kind of situation, either they are parallel to each other or no three planes are intersecting at a time. Here what is happening? This plane and this plane are intersecting. In this point, this plane and this plane are intersecting. In this case, this plane and this plane are intersecting. No three planes are intersecting together. They are not intersecting at a single line or a single point. They are intersecting each other, but two at a time. Here, two at a time. And these are not intersecting at all. Okay, this is deep blue and this is light blue. This light blue and this deep blue, they are not intersecting each other. So that is why these points, these systems are actually inconsistent. They do not have any solutions. Now, in order to find the solutions, how we will see this REF and RREF are connected. How these are connected to each other. So that we will see. For that, we have to give one example. Let me show you some three examples that why I am telling these things, that for unique solution, many solution, and then other. Okay. Let me show you my screen again. Okay, are you able to see this screen now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, right. So let me just copy for unique solution. Let me just show you in the live example. You can use this website for your practice purpose to check whether you are okay. So this is what we get. Let us put enter. Let us check the. Let us change the settings. Okay. You can play with this colors and all other things. Then you can show the plane. You can show the grid line. Then you take the second equation. There is a system. Put enter. Let us change the color here of this plane. Make it 100%. Fill the color. And then have this kind. Okay, let us put some different color, maybe this color. So you can see that. Now you can see this is not intersecting together, but you can see the slope of this this blue, this light blue, and the black plane. They are actually they are making some angle. So if you just if you zoom it, then you can say that there are gap. The gap is widening. But if you just if you look at from the distance, then you can see that they are actually meeting at a single point. This is the point. This point, okay, they are meeting at single point. Here you can see. So this single point, you can see here, this, if you look at from the distance, so all the three planes, they are meeting at a single point. So this will be a unique solution. Okay. If you try to show the plane also, this is from top. Here it is. If you see from bottom, then also you can see that this red plane and the blue plane and the black plane all are intersecting at a single point together. Okay. Yeah. So this point will be, I think, for example, 10, then -3, 5. I have solved this system. So I know that the solution point is this one. So let me put it here in this form. Yeah. After solving this, we will get that this point, this particular point will be, let me draw. We will check how this point is actually getting. Let us first understand the geometry, then we will try to find out the algebraic approach, how to find the solution. 10, -3, 5. So that means this is x equals to this one, y equals to this one, and z equals to this one. First understand the geometry, then you will see how we can find out the solutions. Now we will see another example for which we have for example, infinite number of solutions. Okay, this one. Then there are two equations, three equations again we have. Okay. And then the third equation is this one. So you can see that they are actually intersecting at a line. If you just remove the grid line and the plane also, so you can see all the three planes. This is sky blue, then the black and the red plane. All these three planes are actually intersecting over the line. They have a common line of intersection, not a single point, like unlike the previous example. Now finally, let us look at other example, which is there will be no solution. For no solution, what we have is either either they are parallel, or only two of them will have intersection, not three at a time in a single time. So we are taking the two variable case. X and y are there only. So this is one variable. And then the third equation, let us write. Okay. Somehow this is not working. Let me copy again. So you can see this, that there are three planes, but these are very transparent. So you have to make the color adjustment so that you can get a better view. Go to colors, make it 100%, fill it 100%. Okay. Go to other color. Maybe you can put a black color. Fill it 100%. And the third is, okay, of this form. So this is very useful website where you can play with your problem, plot some graphics, and then other things. You can see here now that only two planes at a time are intersecting. They are not other thing. So if you view it in a three-dimensional plane, in two-dimensional case, so not all the three lines are actually intersecting. So the system is inconsistent. Okay. You can see it here. Either you see it from below or some other view angle. So you can see it here that only two equations, two planes at a time are intersecting. Okay. So now we move to the next. Let us close this. I will put the link so that you can see that you can practice for your own problem. So this is the link, you can work on it. Okay. Yeah, so let us come back again and check what we have seen just now, what we have seen. This pen has changed its shape. So let me just. Okay, right. So we will have these three cases, that many solutions, and no solutions. Okay. Right. So let us see this particular example for which we try to find out the solution. So first task is to also to mention, remember, the solution of the system depends on the coefficients. Okay. But not on the variables. Because you can take the system as xyz, the variables can be xyz, or they can be uvz, uvw also. So there is no issue. If you, even if you think as a different variables also, then it is no problem. Okay, right. So let us see how to get a unique solution and how does the row echelon form and the reduced row these forms are used to find out the solutions. Okay, so here is a problem that we have. Let me just work on it. Sorry. Let me write. Yeah. Solve. This is 2x1 plus 6x2 plus x3 equals to 7. Then x1, 1x1, or you can write just x1 plus 2x2 plus, not plus, it is minus x3 equals to minus 1. And then 5x1 plus 7x2 minus 4x3 equals to 9. Okay. Now the task is to, if you just normally, if you have three variables, then you can see that the graphical plot the planes if they are, if you can see one common intersection point, then you can say that there is a unique solution. And if you are lucky, then you get a solution by the graph, by looking at the graph. But if number of variables are explored up to xn for x100, then you cannot plot this type of graph. So for that, you need to understand the mathematics or the algebraic approach that we do in this case. Okay. So let us write the augmented matrix. What is the augmented matrix? 2, 6, 1, then 7, 1, 2, minus 1, minus 1, then 5, 7, minus 4, 9. You can put a dotted line or you can put just a solid line. Okay. Now we will try to find out REF. So first task is to get the REF, this row 1, and let us do the row operations. So what will happen? R1 and R2 we will exchange. So this will be 1, 2, minus 1 and minus 1. Then this will be 2, 6, 1 and 7. Finally we have 5, 7, minus 4 and 9. Okay. Next what we do? Next we will do the row operations. What we want? We want 0 here and also 0 here. So that means we have to make some arrangement. For that we can get the zeros. So what we have to do? So that means we can do that R2 minus 2 times R1, R2, R3 minus 5 times R1. So if you do these two operations, then you will get 0 here and 0 also here. Okay. We don't bother about what is happening here and here now at this moment. Okay. At this moment, we want 0 in this place. Okay. So let us do that. R2 minus 2 times R1 and R3 minus 5 times R1. If you do that, you will get 1, 0 and 0. After that 2, 2 and minus 3. And then you will get minus 1, 3 and 1. And in the right hand side you will get minus 1. That is 9 and 14. Okay. Let me tell you about these problems. These are very lengthy process, but very easy process. Sometimes you may feel bored that these are too much trivial to find out. But if you do not understand the mathematics, if you do not know the 3 by 3 system, how will we able to solve 100 by 100 or 1000 times? Okay, 1000 by 1000. If you understand this method, then only you can follow these methods. Okay, let me tell you first, there are two things. One is important, another is interesting. Whatever the syllabus content is there are actually important. Whatever we have included in the syllabus, all the topics are important. But it may be the structure of the problem that depends on, not everything is interesting, but everything is important. It may not look interesting to you, this simple operations, because you are doing the same repetitions and repetitions. Okay. So always remember two things. All the syllabus content is important, but may not be interesting. But that does not mean that you will skip these things. Okay. Yeah. So next, what we do? We will try to find out 0 here and also 0 here if possible. Okay, so for that we have to do some more row operations, elementary row operations. Okay, so how do we do that? 3 times, or maybe you can, there is a, you can keep it as it is, because we want to find out this REF. REF, we do not bother about whether it is 1 or 2. The pivot elements is 1 or 2. We do not bother about the REF. But since we want to find also REF, okay.
So,
And yes, tell me.
so we can do R3 is equal to R3 plus 3 by 2 of R2.
Yes, we can do that. We can do that. I'm telling the purpose of doing these things. Why we want actually 1 here. So that the purpose is a row echelon form and reduced row echelon form. They are very, very similar. What is the difference? That means the difference is the pivot elements are 1s. So that is why we can do half times.
So, but what's the use of finding RREF?
Yeah, once we find, you will understand the need. Okay, for that, please keep some patience. So let me solve this problem totally. So 1, 2, minus 1 and minus 1. Don't be impatient so easily. You have to look at the total solution, then only you will understand. So half, then 3 by 2, 9 by
sir.
2. Just tell me.
Sir, in the first step, in the last row, second column,
This
is
is
it
minus,
be
right?
minus 3? Yeah.
Yes, right. Sorry for this. So minus 3, 1. Thank you for correction. Yes, I have done the mistake. Okay, so this is again 14. Yeah, right. Good observation. Okay. And then what we do is R3 plus 3R2. So if you do that, so 1, 2, minus 1 and 1. Okay, 0, 0, then 1, 3 by 2, 9 by 2, and then 0, 11 by 2, and 55 by 2. Okay. So this is actually in REF. REF. It is in REF. So from here you can find out the solution. Now the last matrix, if you try to find out 1, 2, minus 1. If you write it in this form, take last matrix. Then this is 0, then 0, then 1, then 0. This is a 3 by 2. 11 by 2. Then if you write it as x1, x2, and x3. So here you will get minus 1, 9 by 2, and 5 by 55 by 2. Okay. So what happens? You get a system of linear equations now. X1 plus 2x2 minus x3 equals to minus 1. Then this is 0. Then x2 plus 3 by 2 x3 equals to 9 by 2. So the system is actually reduced to of this form. 11 by 2 x3 divided by 55 by 2. So if you solve this, so from here you will get x3 equals to 5.
Hello, sir.
Yes, tell me.
Sir, is this nothing but Gauss-Jordan method?
No, this is Gauss elimination method. I told you this is our REF. When you find REF, this is actually Gaussian elimination. We are eliminating x1 in this equation and x1 and x2 in this equation. Now, because we want to find the solution, so we will use the back substitution. So that is why I asked you in one class that whether you know this Gauss elimination method or not. So maybe you know this method, but the name you may not be familiar. Elimination, sir.
Yes, sir.
Gauss elimination method. Okay. So from x3 you will get 5. Now you will substitute here, back substitution. Okay. From here you will get, so this is x2 you will get, so 9 by 2 minus, so 3 by 2 into 5. 3 by 2 into 5. Okay. And then you will get x2 equals to minus 3. So this is 5 and minus 3 is there. Now you substitute here. Here you will get x1 equals to 2 into minus 3 and 2 minus 5. And the right hand side is 1. So this is becoming x1 is 10. So that's how we got, if you remember, I have shown you somewhere. This point is 10, minus 3 and 5. If you have the system. So in geometry we have seen this. Now we can see the mathematics. So the algebra behind this matrix operations, you can have this. Now once we get up to this, so we can do some few more iterations, few more steps.
Sir.
Start with the.
Sir.
Yes, tell me.
Sir, at the beginning of the problem, we have interchanged the rows R1 and R2. Is it fine by doing any number of times? Interchanging the rows or columns?
Yes, any number of. Because whatever you do, you remember the RREF is unique. It will be unique. Whatever you do, you will end up with the same. Now start with the last matrix. So what was the last matrix? Let us write 1, 2, minus 1 and minus 1. 0, 1, 3 by 2, 9 by 2. Then 0, 0, 11 by 2, 55 by 2, and then this. Okay. Now you do one more step, that is 2 by 11 into R3. Because we want 1 here also. Okay. Okay. So let us do that. So 1, 2, minus 1, minus 1. 0, 1, 3 by 2, 9 by 2. And 0, 0, 1, and this is 5. Okay. So one more step. Let us do. Now you will do that R1 minus 2 times R2. Why? We want to find RREF. So in RREF, what happens if 1 is there except this pivot elements, all others are 0. So we want 0 here, we also want 0 here, we also want 0 here, if possible. So for that, what we do? We do some more raw operations. So 1, this is 0, this is minus 4, and it becomes minus 10. And then what happens is, no, sorry, 2 times. So this becomes 10. Okay. Then 0, 1, 3 by 2, and this becomes 9 by 2. And finally, we have 0, 0, and 1, and 5. So this first column, second column has been taken care. Now we want these two as 0. Let us put the separator line. Okay. So what we do from there is R1 minus 3 times R3. And here it is R2 minus 3 by 2 times R3. So what happens? 1, 0, 0, 0, 1, 0, and then 0, 0, 1. And the separator lines are 10, minus 3, and 5. So this is now is it RREF? Answer is yes.
Yes,
So
sir.
if you rewrite the system, what it will be? You will get a system of x1, x2, and x3. So this is 10, minus 3, and 5. 1, 0, 0, 0, 1, 0, 0, 0, 1. So if you just write down the system, you can directly get the solution 10. System is reduced to x2 equals to minus 3 and x3 equals to 5. Now you can see that whatever you do, you are getting the same solution. Now it may be asked that, so what is the benefit of finding? So this finding this process RREF is known as Gauss-Jordan elimination. Now it is up to you which one is, it is up to the decision maker which one is suitable for them. So it depends on the number of variable and number of equations. That how much, whether we will find the RREF, because if you want to find the RREF, then you have to do some more iterations, some more operations. This is 1, this is 2, 3, and 4. After that, you can get directly from the solution, because this RREF will try to give you the identity matrix kind of thing. If possible, it will give you identity matrix. Okay, if you have 3 by 3 system or n by n system, but if you have a different m number of variables and m and n are different, then you may not get identity matrix, but you will get a simplified matrix. So this is the most simple matrix, simplified matrix. From here you can read the solution directly from the equation. Solutions are 10, minus 3 and 5. The same solution we have obtained in Gauss elimination process also. But for that also we have to do this back substitution. So that means our effort, our computational effort is same. Now this would be difficult. Okay, let me tell you, this would be difficult if instead of 3 variables, if we have more variables for 100 variables, then in the front in the first row you will have so many non-zero variables, and back substitution process will be lengthy. Okay. So that means whether you apply Gauss elimination or you apply the Gauss-Jordan method, the task will be same, almost same, not exactly same, but more or less they will be same. The target is to find the solution. Here you are using back substitution. This is the extra you have to do after finding the REF. And here you are doing some more row operations, but you can read the solution directly. Okay. Now what is the rank of this matrix? Of this matrix is 3. How about this one? If you find out the row echelon form of this matrix,
3.
this is also
3,
3.
sir.
Rank of this matrix is again 3. Okay. Now what will happen if the rank is not 3, instead of rank 3 it is 2, or if it is 1, then what will happen? So these are the case that we can discuss in the next class. Okay. If you have any doubt, you can ask me.
So which method should be preferred then?